Hello everyone, I am Suchita Morel. Welcome you all in the video lecture on the topic lines of regression. We start this topic with the correlation. If two variables are there, x and y, then if x and y are related with each other, then we call this as correlation. If one value is increases, other also increases, that means there is positive correlation. If one value increases, other decreases, there is negative correlation. And if x and y are not related with each other, then there is no correlation between them. If there is a R value, this coefficient of correlation is denoted by small r. And if this value is, there is positive correlation, the maximum value of R is plus 1. If R is negative, smallest value of this R is minus 1. That means R equal to minus 1. If R equal to plus 1, perfect positive correlation. If R equal to minus 1, perfect negative correlation is there. R equal to 0, no correlation is there. Now for this finding R, we apply Curl-Pearson formula, which is denoted by A. For this, R equal to summation x into y upon under root of summation x square into summation y square, where capital X, capital Y, x bar and y bar are these values. If the values of x bar and y bar are not in decimal, then we apply this Curl-Pearson formula for finding coefficient of correlation. If the value of this x bar and y bar in decimal, then we have to apply this formula B. Change of scale and shift of origin. Here, these x bar and y bar are values are in decimal. Then we consider this formula, substitute the values. Here dx is x minus a deviation from assumed mean of x series. Similarly for dy, deviation from assumed mean for y series and with a number of observations, and is r equal to this value, and sigma x and sigma y in terms of dx and dy. Now for lines of regression, here lines of regression which are the linear equations y equal to a naught plus a1x, x equal to b naught plus b1y. The lines of regression for y on x is given by this formula, where r into sigma y by sigma x equal to a1. A1 means this regression coefficient of y on x. Similarly, line of regression of x on y is given by this, where r into sigma x by sigma y, this value equal to b1 and b1 equal to regression coefficient of x on y, where sigma x and sigma y values are these. Now third point, if the coefficient of correlation r is the geometric mean between two regression coefficients for a1 and b1. A1 and B1, we substitute the values, then we get R square. That means R equal to under root of A1 and B1. Now we discuss example on this. Find the correlation coefficient and lines of regression for the given data. Here X and Y pairs are 5, therefore n value equal to 5. X bar is summation of all x values upon n, its value equal to 3. Y bar is 5. Then summation of this Curl-Pearson formula, because these 3 and 5, x bar and y bar are not in decimal, therefore we can apply here a formula, that means Curl-Pearson formula. We find out these required values by using the given data. Here x, y, capital X means x minus x bar, its value equal to 3. Then y equal to y minus y bar and y bar equal to 5. Then x into y, x square, y square. Now for first term, here 1, 2, these are the values of x and y respectively. Then we find out capital X, that means x minus of 3, therefore minus of 2. Similarly, here 2 minus of 5 is minus 3. Then multiplication of these two values 6. Then x square, that means capital X square, therefore minus 2 square is 4. Then minus 3 square is 9. In this way, we find out all the values and find out the summation of these. If when we finding the summation here, summation of x and summation of y always 0. Then here summation of xy, then summation x square and summation y square values are these. We substitute this in Pearson formula and find out the value of r. This value of r always lies between minus 1 to plus 1. This is the first result. Then we find out the equation of line of regression y on x. For this we find out sigma x, sigma y values. Then substitute in the formula and simplify this and write down in the form of y equal to a naught plus a1x. This is the first line of regression. Now second line of regression, we substitute all these values in the formula and simplify this, write down the answer in terms of x equal to b naught plus b1y. This is the second line of regression. In this way, we can find out the lines of regression. Now, second type of example is two lines of regressions are given, these two equations, and sigma x square value is given. Then we have to find out mean value of x and y, that means x bar and y bar. Then standard deviation of y, that means sigma y value. And then the coefficient of correlation between x and y, that means r value. We have to find out these three values. First, here since both the lines of regression passes through the point x bar and y bar, therefore here x is replaced by x bar and y is replaced by y bar in these given two equations, and solve these two equations simultaneously and find out the x bar and y bar value. X bar equal to 1 and y bar equal to 2. This is the first result. Now here sigma x square is given. From this we find out the value of sigma x. And then the lines of regression can be written as y equal to this value. That means here y equal to a naught plus a1x. Therefore value of a1 equal to this value. Then similarly for second equation x equal to, we write down in this form, and this is the value of b1. If we multiply this a1 and b1, we get the value of r. That means the value of r equal to 0.8660. Now here this a1 equal to this is the formula, and b1 equal to this. Now r is known, sigma y is unknown, sigma x is known, a1 is known. We easily find out the value of sigma y. In this way, we find out the different values, that means x bar, y bar, sigma y if sigma x is given, or vice versa. Then coefficient of correlation by using A1 and B1 formula, because R is the geometric mean of A1 and these are the practice problems on these lines of regression. Now, one problem we discuss on the P formula for finding the coefficient of correlation. Here values of marks of M1 and M2 are which are given. Find out the coefficient of correlation. For this we find out x bar and y bar value. Now here these two values are in decimal. Therefore we have to apply second formula, B formula, for finding the coefficient of correlation. Here dx equal to x minus 65, that means this value, and dy equal to y minus 65. We here consider the 65 value, not these decimal points. Then for one value x and y, 80 and 82, for this we find out dx, dy, then dx into dy means multiplication of these two values, then dx square, dy square. In this way, we have to find out all these values, and then taking the summation, then summation of dx equal to 2, summation of dy equal to 6. dx dy equal to this value, then summation dx square and summation dy square. Then we substitute all these values in the formula number B and simplify these. Then we get the value of R equal to 0.9188. In this way, we find out the coefficient of correlation if the values of x bar and y bar, any one value of x bar or y bar in decimal, then we have to apply this formula. Thank you.